So integrating trigonometric functions. Okay, so obviously the easy ones. Okay, so the integral of obviously sine x. This we know it's negative cos x. Okay, so this we know. Then the integral of cos x is sine x. Okay, so these are the obvious ones. Then the integral of tangent x. Did we do this one? Okay, I'll do it still. Okay, so tangent, this you have to do a bit of work. So tan is equal to sine over cos. Okay. And then for this one, we'll do a little substitution. U equals cos x. And so du, the derivative of cos is negative sine x dx. And therefore sine x dx. Sine x dx is negative. Okay, and so this integral is so 1 over cos, so 1 over u, times sine x dx, which is negative. This is negative ln of absolute value of u, and then you replace the u back by cos and you're done. It's negative ln of cos x. I think this question was one of our worksheets. Okay, or if you put the negative 1 to the power of cos, it becomes 1 over cos, which is secant. So you could write it also as ln of secant x. Okay, so either of these two are correct. So this is for tangent. Let's do here the cotangent. So this is the integral of cotangent is cos x over sine x dx, and we do the substitution. U is sine x, u is cos x dx. Straightforward. It becomes the integral of 1 over sine, so 1 over u times cos x dx, which is du. And this is just ln of ln of u. I want to skip a step. C, and this is ln of u, which is sine x plus. Okay, any questions? Okay, let's do a little more complicated one. The integral of, okay, so this one I will do for you, and you'll do the next one. Okay, so secant x dx. Okay, so just remember that secant is 1 over cos. And that's not going to help you much because sine over cos is good because we have the sine x dx, which is du. Okay, almost. But if we put 1 over cos, we don't have our du anymore. Okay, so we have to do sort of a little trick here. We're going to multiply the top and the bottom by something. Okay, so we'll multiply this by secant x plus tangent x, top and bottom. Secant x plus tangent x. Okay, so I did not change anything. Okay, still I'm multiplying this as 1. Okay, so I'm multiplying by 1, so it doesn't change anything. Okay, but why do I do this? Because now, if I distribute the top, I get secant squared plus secant tangent. Okay, so it's secant x tan x plus secant squared x on top. And on the bottom, I have secant x plus tangent x dx. Okay. Looks much more complicated than just secant, but it's much more useful now because I could do u as a substitution, all my denominator. Secant x plus tan x. And if I do the derivative, du, so the derivative of secant is secant x tan x, and the derivative of tan is secant squared.
So how did you get the secant squared x on the top?
This one here?
Yeah.
Secant times secant.
But you kept the other one.
Sorry?
So you multiplied them and then you added it? I don't understand.
Yeah, I did this times this, and then this times this.
Oh, okay.
Okay, secant, I just put it this one first.
Okay.
Okay, you understand my substitution? I did the denominator as a u, and the derivative gives me exactly the top. You see?
How did you,
Sorry?
how did you choose secant x plus tan x?
Yeah, you have to notice. It's a trick. Okay. Eventually, if you do much more math, these tricks are going to become natural for you. Okay, you're going to see a lot of them. We're going to see a few. You already saw it a bit in calculus 1 when you had to find a limit, and on the bottom you had a one minus cos. You multiplied by 1 plus cos. I don't know if you remember. You multiply by the conjugate. Okay, so these are all reflexes that you develop. Okay, but I'm not expecting this from you. Okay, you'll just see this kind of trick in this secant and in the cosecant, the next one. The rest, I don't think you'll need to do any things like this. Okay, so it becomes the integral of, so what do I have here? What's my integral? So 1 over u times, and the numerator is exactly this, right? Secant tangent plus secant squared dx is exactly du. Okay, and so this is the ln of the absolute value of u plus c, and now u, I replace it back by secant plus tangent. It's ln of secant x plus tangent x plus c. So that's my answer. If you do the derivative of this, it should simplify all the way to secant. Okay, so same idea for the cosecant. So we'll proceed the same way as before. I will multiply the top and the bottom, this time by cosecant plus cotangent. top and bottom. Okay, so this becomes the integral of cosecant times, so I have cosecant x cotangent x plus cosecant times cosecant squared, and on the bottom I have cosecant plus cotangent dx. Okay, so my substitution is direct again. U equals cosecant x plus cotangent x. So du, derivative of cosecant is cosecant x. So negative cosecant x cotangent x. And the derivative of cotangent is negative cosecant squared.
Sir, is it cosecant x squared
Sorry.
on top on the right here? Like, so cosecant times cotangent x plus cosecant squared x?
Yeah. I put it so.
No, but is it over the x? It's like between the.
No. It's cosecant x, all that squared.
Okay.
No, you don't understand what I'm saying?
No, just it was in the middle, so I was wondering.
This one here?
Yeah.
Yeah, when I write like this means this. So it means. Okay, don't get confused with this. That's not the same thing. Okay, that's cosecant of x2. And this is cosecant of x, all that squared. Not the same thing. Okay?
Okay.
So all this dx, and so I have negative cosecant x cotangent x plus cosecant squared x dx. Okay, so the numerator now is equal to negative d. 1 over u times negative u. This is negative ln absolute value of u plus c, and I replace u back by cosecant plus cotangent, so I get negative ln of cosecant x plus cotangent x plus c, and that is the integral of cosecant.